What's the most fun thing I do in lab? You're gonna find that I tend to be almost kind of Pollyannish in the fact that I actually really love a lot of different things. One answer is I just really enjoy working with students. I mean, this is one of the cool things about Bucknell in general, and you're gonna probably hear this from just about everyone you talk to. People who are on the faculty at Bucknell, we come here because we like interacting with students. It's particularly fun when I have a student that goes well beyond what I'm talking about. So I had a situation several years ago where the first day of the summer I sit down with the students and I say, well, here are the things that I'm interested in you guys doing. And I sat down and I described the apparatus as how I was thinking about it. And the next day one of the students comes in and she grabs me first thing in the morning. She says, Tom, I've been thinking about what you said and I think I've got a better way of doing it. That's great. That's really, really cool when that happens. I've loved physics since I was 5 years old. I'm a little bit freakish in this regard. In the mid-1970s, there were all these energy crises, and you had to wait in line for an hour to get gasoline for your car and stuff like that. And so I thought, I want to invent something that's going to solve the world's energy crisis. My mother, who, by the way, is a PhD economist, but she said, oh, if you're interested in these things, you should think about physics. And so I started looking at that stuff and realized that I thought it was really cool. When I went to college, I went to college saying I want to be a physics major, but I was thinking at the time in terms of, the kind of the really dramatic stuff you hear, Einstein, Newton, Bohr, relativity, quantum mechanics. And what I found is that my first year course, when we were studying waves, just simple classical mechanic waves, that I thought it was just really, really cool stuff. And that really kind of clinched it for me. This is just two pendulums here, or pendula, whatever the plural of pendulum is. So one of them, and then the second one's on the bottom here. And it turns out that if these things are oscillating with a small amplitude, the behavior is extremely well organized. If you get a big amplitude, so the bottom line here is that even though the system itself is very simple, it can actually display very complicated behavior. Now let me give it a nice good kick so you can kind of get an appreciation for how crazy this can be. They're involved in everything. Absolutely everything. I mean, granted, right now I'm on sabbatical, so I'm actually doing some stuff myself. But in a typical year, the students do everything. They work with me in developing the experiments, coming up with ideas about how to do the experiments. They actually build the experiments. They take the data. They are co-authors on the papers that we write. They go to conferences and give talks on the work as well. Actually, we just had a paper accepted that has 3 students as co-authors on it. In fact, actually, I've had probably 20 or 30 papers since I've come to Bucknell, and all of them except for one have students as co-authors. We bring the students to conferences, and they actually are giving the talks at these conferences. So the answer is they do everything. They do everything.